In this lecture, I'm going to be talking to you about what happens when a star runs out of hydrogen fuel in its core, um, and what kind of star it becomes then. What happens to it at that point? You have or are going to calculate in your homework how long it's going to be until the sun runs out of fuel, and that turns out to be about 5 billion years. So what's going to happen to the sun after 5 billion years when it runs out of fuel? This is the ultimate fate of our own sun, and all stars will eventually go through this phase. This is going to be red giants. Now, red giants, as you know, are pretty big. This one is Betelgeuse, which is one of the biggest ones out there. And this is an actual photograph of Betelgeuse. Most stars, when you take a picture of them, even through the best telescopes, just look like little spots of light. But a few stars are big and close enough that we can actually see them spread out. And this is Betelgeuse spread out. So you can see the size of the star, and then just to get a sense of the scale, they're showing you Earth's orbit and Jupiter's orbit. And you can imagine that if we sat Betelgeuse down where the sun is, Earth and even Jupiter would be inside the star. That's how big a red giant can get. And in fact, they can get even bigger than that. So these things are big. Again, here's Betelgeuse again, and for scale, the sun on this one is so small, it's 1 pixel. You can't even see it. So Antares is another red giant, and so is Aldebaran. Rigel is a very large main sequence star, and it's sort of bluish-white because it's a very hot star. The sun is so small on this scale that we can't even see it. So what makes them red and what makes them so big? That's part of the question. And the other part of the question is, what's going on with the source of energy? Now, this is a process that you're going to have to understand and be able to tell back to me. So you need to make sure you understand what's going on in this process. So because it may take you a minute, I would encourage you to, if you want to try to copy this page, you may need to pause the video and write stuff down, and then come back and listen to the explanation of everything. But this is what happens when the star has fused all of the hydrogen to helium in its core. So the core now consists entirely of helium, and the core is not hot and dense enough to fuse helium into anything bigger at this point. So fusion just stops. Now, at this point, we have to go back and remember what we learned about hydrostatic equilibrium. Remember that we have a balance between two forces, thermal pressure and gravity. Thermal pressure comes from the fusion, and gravity obviously comes from the mass. And gravity tries to pull things in, thermal pressure pushes things out. Well, the fusion stops. So because of that, the thermal pressure is going to decrease. And because of that, if there's nothing to stop gravity anymore, gravity is going to make the core contract. Now, this seems a bit weird because I'm telling you that I'm going to make a giant star, but it sounds like things are getting smaller. We need to look at things in parts. There's 3 sections of the star that we need to look at when we're talking about red giants. We need to look at the core. We need to look at a very thin section around the core, which is called a shell. And then we need to look at the outer layers. So yes, the core is contracting, but the outer layers are what's going to get big. So what happens? Well, outside the core, everything is still hydrogen. The core is helium, but just outside the core we have hydrogen. And it's a very, very thin layer of hydrogen that's right next to the core that we are calling this shell. And it's contracting too. And so it's getting hotter and denser. As things get smaller, they get hotter and they get denser. This layer of hydrogen, and when I say thin, I'm talking about like a kilometer thick out of hundreds of thousands of kilometers. This thin layer, this shell, gets hot and dense enough that hydrogen will start fusing into helium again, but just in the shell. The core is already helium. The outer part is not hot and dense enough to fuse hydrogen into helium. It's just this one little shell. But even that creates a big burst of gas pressure. And And when that happens, that creates an outward push on the outer layers. The shell has this fusion, and because of the fusion, it creates thermal pressure that pushes the outer layers further out. So this is why they get bigger. And of course, when things get bigger, they cool off. So it's going to get cooler. That means it's going to get redder. And it's getting bigger, of course, so that's where the giant part comes from. Now, that's not the whole story, though. It gets more complicated than that. So at this point, what we have, this was the main sequence star. You had the hydrogen fusing into helium in the core, and then you had these other layers that were just hydrogen. In this first red giant phase, we've got the core, which is helium, and that's getting smaller. This shell around it, which is taking hydrogen and fusing it into helium, and then we have the outer layers that are getting pushed outward by the thermal pressure from the shell. You should understand this picture. So, 3 different layers. The outer layers, which your book calls the photosphere, the core, and the shell. Make sure you understand what's going on in all 3 layers. Now, the core is collapsing. Let's go back to the core for a minute. The core is collapsing. And that's all helium, but it's getting hotter and denser because gravity is pulling it down. As gravity condenses it, it becomes hotter, it becomes denser. And eventually, you get to a point where helium is able to start fusing into carbon. And of course, that creates a huge outward push. It's a very, very big burst of thermal pressure that happens when that helium fusion ignites. And so that even makes the outer layers expand further. At the same time, you still have shells burning hydrogen into helium. And if one shell finishes burning hydrogen to helium, then that helium just gets added to the core and a new shell starts fusing hydrogen into helium. So we've got this shell that's gradually moving its way outward, the core, which is now fusing helium into carbon, and the outer layers, which are getting pushed outward and outward and outward by these bursts of thermal pressure that happen whenever a new fusion reaction kicks on somewhere in the star. So that is where we are going to stop. I'm sorry I clicked ahead. That will get us to where we need to be at the end of this lecture, and I'll get to that next slide at the start of the next one.